in today's video, we are going to do some numerical questions from the analog communication subject. We'll be mainly doing questions from the super heterodyne receiver area. Okay. So the first question is like this. So I've only written the required details on the board, and I'll be reading out the question for you. So for a super heterodyne receiver, the quality factor Q is equal to 150. The intermediate frequency, that is FIF, is the intermediate frequency. Okay. It is 455 kilohertz. Signal frequency Fs equal to 1400 kilohertz. Find FIM. FIM means it is the image frequency, and also find the rejection ratio alpha. That is, this image frequency is actually a problem. We have to avoid the image frequency, or we have to reject the image frequency. And what is the rejection ratio alpha? So the two things we have to find: the image frequency value and also the rejection ratio. Okay, so let us see what are the equations and how to do this question. So for first we'll find the image frequency, and the equation is FIM is equal to Fs plus, that is signal frequency Fs plus 2 times the intermediate frequency. Okay, so this is the equation. Image frequency, I'll write it here. So image frequency FIM is equal to Fs plus 2FIF. Okay, now what is Fs? It is 1400 kilohertz plus 2 into 455 kilohertz. So there is one important thing, that for mostly all super heterodyne receivers, the intermediate frequency is actually tuned to 455 kilohertz. This is the commonly seen intermediate frequency. Okay, so this will be common in most cases. Okay, here the value. So on solving, the value you will be getting is 2310 kilohertz. Okay, so the image frequency FIM you will be getting is 2310 kilohertz. It's actually very simple to solve. You just have to take the product of these two. All the values are in kilohertz, so simple, right? So the answer you are getting is 2310 kilohertz. So we have obtained the value of image frequency. Now next we have to find the value of alpha. So the equation for image frequency rejection ratio alpha is given by alpha equal to square root of 1 plus Q square rho square. Okay, so this is the equation, square root of 1 plus Q square rho square. Okay, here Q is directly given in the question, which is a quality factor. We need to find the value of rho. Again, how to find the value of rho? Rho is actually given by the equation F image frequency FIM by Fs minus Fs by FIM. Okay, Fs by FIM. So this is the equation. So the equation for rho is FIM by Fs minus Fs by FIM. So just substitute the values here. You will be getting 2310. All the values are in kilohertz, so you don't need to put the unit. 2310 by 1400 minus 1400 by 2310. Okay, and on solving you will be getting the value of rho as 1.043. Okay, so you just have to substitute the values of Q and rho here. So alpha will be equal to square root of 1 plus Q is 150 square into 1.043 square. Okay, so this is the value, and you will be getting alpha is equal to 156.453. This is the value, and again generally we substitute this, or we find the value of alpha in dB. So value of alpha you are getting is 156.453. But generally we express alpha in terms of dB. So take 20 log 10 of alpha, and you will be getting, that is 20 log 10, 156.453, and approximately the value you are getting is 43.8 dB. Okay, 43.8 dB is the value of alpha obtained. Okay, so this is how you find the value of the image rejection ratio, which is given by alpha. Okay, so this is the equation. Alpha equal to square root of 1 plus q square plus, q square into rho square, okay, together square root, okay. And you have to find the value of quality factor. Quality factor is directly given in the question, and also the value of rho. So rho is given by this equation, image frequency by signal frequency minus signal frequency by image frequency, okay. So this is how you do the questions on image rejection ratio, and this is the equation to find the image frequency. FIM is equal to signal frequency plus twice the intermediate frequency, okay. So the next question is this: let MT is equal to cos 4 pi into 10 raised to 3t be the message signal. CT or C of t equal to 5 cos 2 pi into 10 raised to 6t be the carrier. Modulation index of AM is 0.5. You have to find the value of this fraction, that is the value of total sideband power to carrier power is dash, okay. So for doing this question, you should be knowing what is the power equations of AM. So the power equations are: the total power PT is equal to carrier power PC into 1 plus m square by 2. So this is the equation for the total power of an AM wave, that is including the two sidebands and the carrier. But if you are only considering the sidebands power, total power contributed by the two sidebands, the equation is like this: PSB, let PS be the power of sidebands, that is total power constituted by the upper and the lower sideband, okay. Then the equation is like this: PC m square by 2. This is the equation, okay. Here PC is again the carrier power, m is a modulation index by 2. So this is the only equation that we are requiring. Now from this equation we don't need to find anything. We need to find the value of the ratio PSB by PC, okay. So PSB by PC is equal to m square by 2. So this will be the unit coming, okay. Here PSB is the total sideband power by carrier power. So this is what we need to find, okay. So total sideband power to carrier power, that is equal to PSB by PC equal to m square by 2. So substitute the value of m here. M is 0.5 square by 2, okay. And solving, you will be getting the value as 1 by 8. Okay, so this is actually a previous year GATE question. So these type of questions you can expect. Actually the question is very simple. Only thing is you should be knowing this equation. If you know this equation, it is easy. Otherwise it is difficult to solve from this. From the total AM power equation, it is difficult to solve. You should be knowing this equation, okay. So the equation here is total sideband power is equal to carrier power into m square by 2, where m is the modulation index, okay. Is this: for a message signal m of t equal to cos 2 pi fm t and carrier frequency fc, which of the following represent an SSB, okay. That is, SSB means single sideband. Out of these 4 given options, which one is representing a sideband? That is the question, okay. So how will you write the equation for the modulated signal of an AM wave? So this signal equation, so here from the given options you have to find which option is corresponding to a sideband, okay. So the modulated signal for the question is given by the equation S of t equal to m of t into the carrier cos 2 pi fc of t, okay. So here you have to substitute the value of m of t as cos 2 pi fm of t into cos 2 pi fc of t, okay. And on solving you will be getting it is 1 by 2 into cos A cos B is equal to cos A plus B plus, it is 1 by 2 cos A plus B plus cos A minus B, right. So you can write cos 2 pi into Fm plus Fc of t plus cos 2 pi Fc minus Fm of t, okay. So from this equation, so this will be the equation which is having only 2 sidebands, and This is the upper sideband and this is the lower sideband. This is having higher frequency, that is FM, FC plus FM. So it will be upper sideband and this is the lower sideband. And if you see the options, only this option, that is option C, is having the equation as same as that of the sidebands. So this is the sideband. Okay. So if it is FC minus FM also, then you can take that option also because it is representing the lower sideband. So this term represents the upper sideband and this term represents the lower sideband. So we have to pick any of these sidebands or which equation is actually corresponding to any of the sideband. So the equation is in the option C. Okay. Correct answer is option C. So the fourth and the last question that we are going to discuss in this video is this. For a super heterodyne receiver, FIF, that is intermediate frequency, is 15 megahertz and the local oscillator frequency, FLO, is the local oscillator frequency. Okay, that is 3500 megahertz. If signal frequency is greater than the local oscillator frequency, find the image frequency. These type of questions you will be facing in your exams. Okay, so we will write down all the given details. FIF, that is the intermediate frequency. I'll write it here for you. Intermediate frequency, and that is 15 megahertz. Then local oscillator frequency, FLO. Local oscillator frequency is 3500 megahertz. Then signal frequency, F, signal, it is given that it is greater than the local oscillator frequency. Now, when the signal frequency is greater than the local oscillator frequency, the equation for finding the intermediate frequency is like this. Okay, FIF, that is the intermediate frequency, this value is found by two equations depending on whether the signal frequency is greater than local oscillator frequency or it is less than. So, when F signal is greater than local oscillator frequency, then the equation for intermediate frequency is like this. F signal minus FLO. Okay. For the second case, so this is case 1. For the second case, when F signal is less than the local oscillator frequency, then the equation is like this. F LO minus F signal. That is, whichever is the higher value, we are going to subtract the value from it. Okay. So here, this is the condition. Only the first condition we have to follow. That is, the signal frequency is greater than the local oscillator frequency. So we can simply ignore the second condition. So here, F signal minus FLO. We need to find the signal frequency. Other two things are already in our hand. So from this equation, let this be equation number 3. Okay. So F signal is equal to FIF plus FLO. Just take this to the other side. Okay. So you just have to add the two values. And on adding, you will be getting 3, that is, here it is 15 megahertz. Both the values are in megahertz, plus 3500 megahertz. Okay. So you will get 3515 megahertz. So this is the signal frequency. We don't need the signal frequency. We require the image frequency. Okay. So now what is the equation for image frequency? In this case, the image frequency is FIM. You can take FRF minus 2FIF. Okay. Since the signal frequency is greater than the local oscillator frequency, we are going for this equation. Okay. FIM is equal to FRF minus 2FIF. Okay. So here, okay, we'll call it as F signal. So F image frequency is equal to signal frequency minus twice the intermediate frequency. That is the equation. Signal frequency is 3515 megahertz minus 2 into 15 megahertz. Okay. That is 3515 megahertz minus 30 megahertz. 3485 megahertz will be the value obtained. Okay. So the value obtained is 3415 megahertz is the value of image frequency that you're getting. Okay, so this is the equation. Okay, so these are the questions which I have included in this video. I've tried to include different questions from different areas. We'll be doing more these type of numerical questions from the analog communication subject. There are different areas actually. Frequency modulation is there, phase modulation is there, different type of modulators are there. All those areas you can find small problems based on the equations. Okay, we'll be doing those numericals in separate videos. Okay, so anyway, if you found this video useful, please do give it a thumbs up. Please do share it with your friends who's preparing for any examinations or if they are interested in studying the analog communication subject. And also if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.